Hello, and welcome to today's webcast brought to you by LEDs Magazine. I'm Editor-in-Chief Maury Wright. It's my pleasure to host today's presentation, Stick to the Clear Advantage, new patented DOWSIL EI-2888 primerless silicone encapsulant for LED lighting. Today, our speakers will be Julian Renaud, Thierry Koermans, and Konstantin Sobolev from Dow Silicones, Belgium. We'll get started momentarily, but I'd just like to make a few announcements and cover some logistics first. First of all, the presentation is intended to be live and interactive. You can ask questions at any time by clicking on the Ask a Question button there in your presentation window. No need to wait until we get to the Q&A session. Just go ahead and type those in as they occur to you. I'd like to thank our sponsor today, Dow Silicones, for making this presentation possible. For all of you in the audience, the presentation will be available on demand within 24 hours of the live event. We'll send you an email with a direct link to that on-demand version. You can always, of course, get to our on-demand webcast just by going to our homepage, ledsmagazine.com. Just look for Webcast up in the top horizontal navigation. We do have a few resources available for you today. If you look at the event resources section of your console there on the lower left, there's a drop-down arrow, and you'll find some technical data sheets there for you. We will offer a copy of the presentation in PDF format for anyone who completes a brief survey later on in the event. I would remind all of you that we obviously offer these webcasts on PCs with browsers, but also on mobile devices, and so you can experience them, however you wish. Our topic today is ultimately on optics, and that's an incredibly important element to solid-state lighting at both the component and system levels. And while you may not think about optics as being maybe in the spotlight in every instance, they really are incredibly important part of the mission of delivering optimal light quality and color quality, while also really boosting reliability and performance of systems in harsh environments. So just briefly to introduce our speakers, Julian Renaud is a Technical Service and Development Senior Professional for Advanced Assembly Solutions at Dow Performance Silicones. He's worked in end-use application development using silicones for more than a decade. Thierry Koermans is a Technical Service and Development Specialist for Advanced Assembly Solutions Europe, and since 2011 he is focused on production to end-use application development. And Konstantin Sobolev joined Dow in 2005 and has led business development over both new geographies and new and various applications, including automotive, lighting, and industrial. So, Konstantin, I think you are leading off today. The floor is yours.
Thank you very much. And hello, everyone. Let me introduce you to the agenda first. And on the first part, which is dedicated to how do we see the lighting market in the future and the evolving customer needs, and how we actually plan to respond to those customer needs with our new technology. This will be covered by me, and then I will pass over to my colleague, Thierry Koermans, who will share with you the overview of the different solutions currently available on the market and compare them to each other. And then finally, Julian Renaud will actually introduce the product, including its features and benefits and performance details, and I will come back on air once we come to the cost benefits of this material for you. So with regards to the LED lighting market, for sure it continues to grow, and LED lighting market will continue to outperform general lighting market per se in terms of growth. As you can see on the slide, it is expected to reach very significant number quite soon. And when it comes to the growth rates, one may conclude that if the volume growth is way higher than the value growth of the market, then the cost pressure remains quite high for the LED lighting market, and I personally agree with that opinion. And at the same time, we all contribute to the sustainability of the industry. As you can see on the slide, we expect that LED penetration will positively impact the energy consumption related to lighting. When it comes to the addressing the needs, let us zoom in on the professional lighting market, which is significant by its own. And when we say professional lighting market, we mean different industrial applications, commercial use, outdoor of many types, and architectural applications. And the main growth drivers for this market are somehow linked to the intrinsic properties of LEDs when it comes to the high efficiency and low power consumption. At the same time, you could see those points marked in red on the slide. This is where we expect our new technology also to contribute to the growth, like with the high reliability and robustness, high brightness over time, and allowing you to do it in any shape that application actually requires. When it comes to the protection, when it comes to the reliability and robustness, right, there are different types of applications where the need for the higher protection is better pronounced. And of course, we talk about professional, flexible, and rigid LED strips. When we say rigid, we mean those ones in the different type of aluminum or other material profiles, outdoor LED displays, and of course, explosion-proof lighting, or lighting for the harsh and hazardous environment. And these can be as well of different shapes of forms, like linear or spot and flat and general area. And of course, there are a lot of specialty type of lighting on this market. When it comes to the protective materials, we have been to this market for a very long time, and actually we pioneered the silicones for optics when lighting became an LED lighting. And of course, we were thinking hard about the protective solutions, and we are, of course, in conformal coatings, in optical encapsulants, and Thierry will talk more about it later, molded silicone lenses. At the same time, the conclusion has been reached that when it comes to the harsh environments, encapsulation is the best suited option for such kind of luminaires, especially for the explosion-proof, or in case you really would like to reach high ingress protection rating. With that, before going into the Thierry's part, I would like to say that what we have found out when we have been working on this project or in the protection for LED luminaires, that sometimes customers need to compromise between protection and performance for many different reasons. And hopefully the solution that we will introduce you today will actually eliminate this need for compromise between the protection and performance. So with that, I would like to pass over to my colleague Thierry, who will introduce you the protection solutions currently available on the market, their benefits and limitations in greater details. Thierry?
Thank you, Konstantin, for this introduction. So let's now continue to the overview of the optical influence of the existing solutions on the market. I'm sure a lot of you already know the possible effect that we can have by putting any molded lenses, encapsulant, conformal coating on top of a bare LED, like the change of the Fresnel reflection of the light path of the light source, leading to some color change, or also leading to a change of the total internal reflection of the light in the LED chip itself. Now, regarding the existing encapsulation materials on the market, we have three big categories, three big players, where we can find, of course, the epoxy, one of the hardest material on the market that can offer the best mechanical protection, so really used for application where you have a heavy mechanical stress on the luminaire. The epoxy develops as well very good adhesions to many range of substrates, and of course linked to this kind of technology, it's well known that epoxy are very low-cost materials. Now, regarding the epoxy, we have on the other side some limitations. As some organic material, we have, of course, some very weak photoresistance. So, again, UV sunlight exposition, where the materials start to become yellow, brittle, and so on, and losing all these main advantages. Other aspect as well is the shrinkage that can occur during the curing, and this can lead some big issues when you have very long and very complex shape of with your luminaire, and also a lot of health concerns regarding the technology itself, the chemistry that's behind the epoxy materials. Now, going to the urethanes, one of the big advantages of the urethanes are, of course, the tunable hardness. So this is really a material where we can tune the hardness to very soft to very hard material. We have as well some adhesion to substrate, but in some cases with some limitations. And as organic compound, we find it on the market with medium price, with also some high price, depending of really the specialty of the urethane. On the other side, the urethanes like epoxy shrink during the curing, so leading to stress. So also could create a lot of damage to the module, bending linear modules, breaking some sensitive wires, and so on. Urethanes are as well known for their sensitivity to moisture during the curing. This is a very difficult topic for the process line because this leads to bubbles in the final luminaire, and of course impacting the light output of the light. Other aspects, additional aspect that is really important, I think, for today are health concerns for the workers. So isocyanates are well known to be harmful for the humans. And now coming to the silicones. Silicones are of course known for the highest thermal stability and photoresistance. So UV sunlight or temperatures up to 150 degrees are something that is easily manageable with these kinds of technology. We have, of course, good moisture and humidity resistance. I think we have some good examples with some construction or big windows, ceiling, or adhesive application for the buildings that are there since decades. And a big change regarding the organic compounds is that the silicone presents no exothermic reaction or no shrinkage, meaning that you can really apply the material in a broad range of length, shape, thickness, and so on for your luminaire. The silicones that are for the moment on the market present no adhesion for many substrates and need additional primer to develop the good adhesion and target a high IP protection for your luminaire. This additional step, of course, leads to additional cost of the assembly of the luminaires. Silicones are also well known as high-cost materials, and they present, especially for platinum or addition cure system, some issues with particular components of the luminaires that leads to inhibitions and bubbling of the material. Now let's compare those three different technology regarding really the properties to luminaires application. So light transmission is of course one of the number one need, and of course as we are looking for epoxy, urethane or silicone optical grade, we can see that all of those technology can offer a very bright solution. The other aspect, especially for outdoor application, is the aging resistance. As I told before, organic solutions are weak to UV sunlight or very high heat exposition compared to silicone. Processing, so the processing take in account the mixing ratio and also the different viscosity of those technology on the market. So epoxy is generally present in a different kind of ratio, this leading to sometimes very special mixing procedures and so on. Urethanes, they are typically in a 1-to-1 ratio, which is really easy to apply. Now for the silicones, what is currently on the market, we are a bit in between where we can find various or many two mixing ratio from 1-to-1 up to 1-to-10 mixing ratio. For those three technologies regarding the viscosity, we are mainly in the same range of viscosity, which is really easy for the processing of those materials. Rapid room temperature curing. All those materials present quite good and quite fast room temperature curing, and sometimes with some options to even accelerate the curing for the silicones at a higher temperature. Self-adhesion. Epoxy is there very strong with their chemistry. Urethane, we could develop some adhesion with some limitation on very specific substrates. And there we have really the red box for the silicone, where no adhesion is developed at all with the current solutions. Health concerns, organic compounds, as already mentioned, present some irritant or toxic substances, which is not always very funny for the workers. On the other side, silicones are more health friendly. Shrinkage and exothermic reaction as well. We can see that for the organic compounds we have some issues. As for the silicone, we have none of those limitations. It avoids really to create luminaires with original shapes and texture. Cure robustness. Epoxy is very robust. The urethane, we saw it's very sensitive. It's sensitive to moisture. And silicones really linked to the quality of the different components or wires used in the luminaires. Now, regarding the last parameter, which is, I think, important for everyone who is manufacturing luminaires, is the cost. Organic compounds are generally at lower cost than silicone materials. And what we see in this table is that we have kind of three main limitations for the silicone: is the self-adhesion, the cure robustness, and the cost. And this is something we would like to address with our new solution.
Thank you, Thierry. Julien Renaud speaking. Hello, everyone. So I will have the pleasure today to introduce our new solution in the name of DOWSIL EI-2888. Primarily silicone encapsulant, and we are all quite a bit excited with this new technology here, and I will try to share that with all of you today. So as Thierry exposed recently, the requirement of the market in terms of all the properties for an optical encapsulant has always some limitation with the existing technologies. We try to develop a completely new solution with a new chemistry that has been recently patented. That's the aim is to almost tick all the boxes that we just explained, and we will elaborate on that to give you some flavor. There is as you can see, only one that has some limitation that I will cover within more details. Again, this product is a 100% silicone product. It's not an hybrid at all. So just to make it clear in terms of chemistry, that it can bring also all the advantage that comes with silicones technologies. So first, we said it's a primerless product. So we have seen Thierry expose just before that actually on the market there is no silicones that can be considered really self-adhering. When we are talking obviously about optical products, we are not talking about products that are filled or not transparent. Here we are really tackling the optical application. Why? Because most of those type of products, when you are exposing them to aging, they have tendency to discolor or to have some optical defects, and that was all the challenge that we had to face with this new development. So as you can see here, we have developed a product that can build reliable adhesion on various type of substrate that are used in the lighting industry today. Of course, it has some limitation, and I would say that it has traditional limitation of very challenging substrate like PMMA type of substrate or some die-cast aluminum, where the cleaning has a high influence on the adhesion of the various products. But these limitations are not limited to this technology. But majority of the other type of substrates in the name of anodized aluminum or FR4 boards, stainless steel, polycarbonate, PBT, different type of plastic, we really have good adhesion. You see a few pictures that we really reach cohesive failure on a different type of substrates that we have tested. And these testing were also done after some quite harsh aging. We have tested several thousand hours, and we continue to test those, but we have been up to 150 degrees, very high humidity, high temperature, thermal shock, and of course sunlight UV. But for silicone, sunlight UV, it's quite easy passing type of test in general. So just to expose with some picture what we can reach here, we just compare the existing new product with some optical grade PU. So that's a PU that is sell today for optical application. So this is not a standard type of product. Just to compare, this product is certified to support 120 degrees permanently, but we don't know for how long, and obviously that this is not that long, as you can see here, because after a few hours already you start to discolor at high temperature, and over time this become worse, and when you see the product that becomes really red or brownish, it becomes really hard and it starts to crack. So that's where you have issues when you have to pass very difficult testing at high temperature. This is not the case for a product like the current silicone on the market, but again, the objective was to keep the advantage of the existing silicone, but to overcome the limitations. So you can already see these were done in 5 mm sheets after several thousand hours, and again, the testing is still ongoing. To go into more optical data, we measured the optical transmission of our product again in sheets, here 3 mm after the various exposure. You see that the transparency is quite exceptional, especially when you age the product to UV. You can even find that the product is improving over time, which is a quite unique feature. The transparency is better after UV exposure than after the first curing minutes. When you look to high temperature, of course, you start to see some slight yellowing in the low wavelengths of the product. Again, the higher you go, the worse it goes at the beginning, but after some times, interestingly, we also see that the product is improving at very high temperature, which leads to this curve here, where you can see that the 150 exposure is even better after 5,000 hours than the 100 degrees exposure, which is also quite unique. In terms of optical transmission, we are not as good as optical existing silicone product in our product range, but that needs primer. But compared to those, we build adhesion at room temperature, and for the majority of the application, the running temperature that we had validated is generally lower than 150. We are most of the time talking about 100 degrees to 120 degrees, and the optical performance remains exceptional in those range, and nothing to compare with urethanes type of product. We also run some testing on real application. So we just run for also several thousands of hours high power LED modules, so overdriven to go to the extreme condition with some high temperature. What we wanted to check here was to say, okay, as Thierry explained, we can have some color shift when you put some when you encapsulate some LEDs. This is a well-known factor. This is still true here because of the Fresnel reflection. But what we wanted to highlight is that there is no change over time. First in luminous flux evolution, and also in CCT, so in correlated color temperature of the light that is going out of the luminaire. So as long as you can manage the shift from from the beginning, like with every other type of encapsulant is the same, the property remains stable. One of the main limitation of the existing silicone, so there are a majority of them, and nearly all of them are based on platinum catalyst system, are leading to what we call Q poisoning or inhibition. This is a phenomena that happens when you have contaminants on your board or on your components that can inhibit the cure and the chemistry, which leads to uncured product, so liquid product at the end. So which is a defect for the application. When you are facing that, this is generally due to either solder flux that are from bad quality or bad cleaning of the board, or cheap component that can have some volatile in there, creating a lot of issue. With this chemistry, so far we have not seen any inhibition with all the different testing that we have done. With various application and various customers as well. This has never been seen like with the other chemistry, as we are talking about something completely different here. As compared to urethanes, the product is not sensitive to moisture during the cure. This means that you will not will not lead to micro bubbles in the cured product at the end. So you don't need to control really the atmosphere and the moisture in the environment where the product is used. So it's relatively easy to use. All this leads to also a capability to have lower cleaning requirements, because mainly of the inhibition that is less sensitive, and that there is less impact from the different component on the product itself. So it's again a potential cost savings at the end for your application. The ease of processing, that's a collateral advantage that we discover over time with the development of this product, is the degassing performance of the product is really exceptional. Just took an example here that we did in our lab by just mixing by hand the product. So you encapsulate a lot of big bubbles in the product that you can see on the left. But after already few minutes, almost all the big one have completely disappeared, and after 1 hour, the product is crystal clear and very smooth surface, and no issue with bubbles encapsulated in the product at the end, even without applying any vacuum. So this is linked to the product properties together with the low viscosity of the product. So no need of vacuum. The product is a 1-to-1 mix ratio. So as Thierry said earlier, some products have more exotic mixing ratio that are more difficult to manage over time. Here, the aim was to make it easy for the user. One thing that was one of the thing we wanted to validate at the very beginning of our project is that the hardness of the product is relatively limited in terms of high value. So you can see here that after several days, the maximum hardness we reach is in the low shore A range, which means still relatively soft. And on paper, many customers and many people we discussed with were a bit scared about these values. But after feeling and touching the product and using it for real application, the feedback was completely different. Yes, indeed, it's relatively soft, but for majority of the application, silicones is never used in luminaire that are put in the ground, for example, where to have to work on it, because even the existing products are too soft. And this one, this softness can also bring some advantage by releasing majority of the stress that you can find on the large modules and the variable environment with temperature cycles and so on that you can face. So the product is curing, let's say, a bit slower than the existing technologies in terms of silicones, again at room temperature. But as long as the product is jellified, so let's say it starts to form a gel after a few hours, you can already handle the parts with very good adhesion. And after a few days, the product hardness is really sufficient to hold majority of the application. In parallel to that, you can accelerate the cure by applying some heat to the product, as you can see on the first line, and I have some more details afterwards. So here are the evolution of the hardness. So it's also an image of the evolution of the cure of the product. You can see on the low side that if you apply some heat compared to room temperature, you can divide by 2 or 3 the cure time of the product. So that's an option. But over time, the product will build the hardness, and adhesion is quite immediate with the product. So still very good performance in that purpose. This is exactly the same value. So we evaluate that if the product is exposed to high temperature or thermal cycles or high humidity, we have no drop in hardness. So those two graphs are exactly the same samples. They are just on different scale. On the short 00 on the left and the short A on the right, you can see that there is more variability on the short A scale because we are in the low side of the range. But these are exactly the same sample, and you see that the value are really stable over time. So if I compare to the example I took at the very beginning, the urethane, when you expose them to high temperature, those products have tendency to harden over time, which can lead to crack. That's why in the case of explosion-proof lighting equipment, when you have to test at temperature up to 150, this product is not passing the test because this crack after several days. This will not be the case with this type of product. I would like to touch a little bit about the tackiness as well, because so many people can perceive that relatively soft product can be perceived as really tacky. We can tell you that all the feedback we receive from all the customers who have tested this product, yes, indeed, after a few hours, the product start to form a gel. So when you have a gel, the product is tacky, but after 1 or 2 days, the tackiness is lower than any of the silicones that we have tested so far. So the tackiness is really good properties when the product is fully cured. In terms of electrical properties, so we are talking about protective material. So the one of the main parameters is to be sure that the electrical properties are kept. So for this purpose, you can see that those values are quite standard values for silicones product, and we are not worse and not better than others, but we are we are really good for majority of the application in terms of electrical performance. Shelf life, so usable life. Also, one thing that could be problematic for some customers, some application, is when you are going to a relatively short shelf life product. Here, really our target is to have a 1 year shelf life product. This is what we have validated so far, and all the properties remain stable over the aging condition. Even in accelerated aging condition, we have not seen any limitation with the product. So the 1 year should be expected without any issue. One comment here. The product is a two-component product. One of the components is insensitive to moisture. So basically, if the packaging is open and reclosed, some moisture can go in and creates issue. So the main thing is to avoid moisture contamination. It could be that does not mean that you cannot open and close the packaging. It's just that you have to prevent that the moisture can stay in the large quantity in your packaging, either by just purging with dry air, or nitrogen is even better, but that's not absolutely needed. On the other hand, even if you have moisture contamination, this will lead to some decrease in the cure speed. So this means you can still use the product, but you should not expect the same cure speed as the initial value that we show you. But at the end, the product still remains optical and will cure anyway, so still usable. One interesting feature that I want to share with you as well to this product, and because we had some customer who were quite interested into these features, is that the ability to bond the cure material to some substrate. So the process that you have to use in this case is you just take the substrate where you want to bond the material to. You apply some primer, like DOWSIL 1200 OS type of primer. You just wait 5 minutes for the primer to react. And on the counterpart, you apply your cured product. So in this case, I just took an example of an encapsulated LED board, so meaning that the board is protected with our DOWSIL EI-2888, and you just want to bond it to the substrate. So for example, let's take the example of a window where you want to glue some LEDs and still bond it and protect the LEDs with an encapsulant, but you want to bond these encapsulated LEDs to this glass because those LEDs have to illuminate the glass. So you cannot use a standard adhesive that is not optical. And finding good optical adhesive is not easy, so majority would have to use a mechanical fixation. In this case, you just wait 5 minutes after applying primer, you stick the cured product on the glass or every other type of substrate, even plastics or some PMMA, it's working as well. And it's directly bonded, and it's chemical bonding. So basically, you have quite good bonding with this technology, and can bring some new features, and no need of mechanical fixation for your LED in your glass in this case.
Thank you, Julien. I think it was a lot of information for everybody. So let's resume a bit what we saw in the last slide. So again, we are there with our table comparing the epoxy, urethane, and silicone, and we will especially look more in detail regarding the silicone materials. So our big limitations of the silicones were the self-adhesion, the cure robustness, and the cost. Regarding the processing, we see also that there is a big change for this new EI-2888, as this new material is presented with a mixing ratio of 1:1, so really easy to use. And Julien mentioned it as well. It is very difficult to degas this material, even without any applied vacuum on the module. Rapid room temperature cure, you see that we have some limitations, especially regarding the addition cure of the previous silicone encapsulant versions. It takes a bit more time, but yeah, pro and cons have to be considered for each application. Self-adhesion, we see there we pass from a big red to a fully green boxes. So this is really one of the main USP of this new material, that we develop primerless adhesion on typical substrates for the lamp luminaire assembly. Q robustness, we are here with a very robust chemistry that, as we already said, for the moment we still don't show any inhibition or cure problem. And I will let Constantin cover the cost line. Yeah.
Thierry, thanks so much, and Julien, thanks so much for the great introduction of the product. Before I go into the cost or price positioning topic, there are a couple of questions we want you guys to answer through the poll. First one would be whether you would like to receive a sample of that material for your tests, and with regards to the package, we will elaborate on the next slide just after the pricing, and whether or not you would like to receive the copy of the presentation straight after the broadcasting. So those two polls. So please answer the questions. I hope you see how it looks like. And meanwhile, let me elaborate a little bit on the price positioning and why we do it on this particular slide, because the cost of the material is also an important benefit to you, along with other properties listed on the slide. And going a little bit more precise, people may ask the question, hey guys, does it mean that this silicone material is comparable in price with polyurethanes? And this is a tricky question because, of course, EI-2888 will not be, or we do not expect it to be, on the same price per kilogram, right, or per pound, compared to the polyurethanes or optical polyurethanes available on the market. At the same time, we have done an effort to make sure that the cost of this material is lower than the cost of available silicone solutions. And I can tell you, I got the discussions personally with a couple of customers with whom we were validating this technology while developing it. And people were telling us, you know what, even though cost per kilo could be maybe more expensive than polyurethane they currently use, with all these benefits listed on this slide, even from the total cost of ownership or the cost of production, it might perfectly happen that using DOWSIL EI-2888 could be more beneficial for you guys than using the polyurethanes. This is what I want to say on the cost. So with regards to the packaging, these are the pack sizes currently available. So the standard pack sizes that we expect that you can already pretty much order through the closest DOWSIL distributor in your region or country. So they are available in so-called jerry cans, 90 kilos, and standard drums, 200 kilos drums. At the same time, to support the promotion of this material, we made a specific dual cartridge sample package, and you could see it on the screen as well. And it comes in the aluminum foil because we would like to prevent any moisture uptake through the plunger or whatsoever when it comes to the cartridges. And again, as Julien said, there is no such an issue for the standard package like jerry cans and drums, as long as you keep them tight and you take care of them while you're stocking the material. Technical and safety data sheets. I just checked our consumer.dow.com website before going live or on air with this webinar. So the technical data sheets are available. Go there and download, and as well they're available as the additional sources at this webinar. On behalf of the team, I would like to thank you, and we are ready for questions.
Very good. Lots of good information there. So let's jump right into the questions. This attendee says, we have used silicone for encapsulation, but when it is exposed to sun, it does change color and then it stabilizes. which means no further color change. Can you explain that phenomena?
Yeah, I can answer this one. So this is related to the traditional technology that is used for silicones. So I was talking about it. So you have some platinum cure system. These type of technologies are known depending on the formulation of those silicones. So it can vary from one to another. That's why we always suggest to go for optical grade type of silicones, because standard transparent type of silicones made of this chemistry can show this kind of effect and leads to yellowing of the product over time. This is linked to this is inherent to this technology, but can vary from one product to the other depending on the formulation. So this is a quite well-known phenomena. Here for our product is quite different because we are talking about a completely different type of chemistry.
Okay. This attendee says, we have had adhesion issues with silicone. The encapsulation tends to peel off in most cases in our applications. Can you suggest any particular cares or procedure to follow?
So I can answer this one. It's Jerry. I would say just choose the EI-2888 as this really presents some primerless adhesion on many substrates. The typical issues we have with standard optical and silicone is that there are no real adhesion developed during the curing.
So I think this is relative to one of specific of your slides. You were talking about 2,000 hours of exposure, and this person asked, 2,000 hours exposed to each parameter individually or in combinations?
So it was, in our case, individually. So we made different samples and exposed them separately to these conditions. So either thermal shock, high humidity rate, high temperature. But also in parallel, we have run some other testing where we can have one after each other depending on the testing. We have done some testing around that as well. And we have not seen a major issue related to that so far. Of course, we have not run for 10,000 hours all of them. That's our objective. But yeah, still some time to go on with these testing so far. Thank you.
Okay, I think this one is for Julian. Have you tested some plasma surface preparation also on PMMA?
The answer is no. We just tested the bare component, just a little bit of cleaning. We have not tested with plasma because this can induce some variability. So, but of course, at the end, we could have seen improvement on the adhesion, and this is a well-known technique to improve that. But as our ultimate objective was to develop an easy-to-use product that you just have to apply to stick on substrate, the testing was made for that purpose. So we have not tested any plasma, and maybe this could significantly improve the performance. In parallel to that, I said that the techniques of using the primer to bond the cure product, on this one we have seen that we were able to stick on PMMA with the product. But again, then it's another objective because you have to attach or to adhere cured product with the use of some primer. So that's a different purpose.
This attendee asked, can you injection mold lenses using this material?
So the viscosity of the material allows you to do some injection molding. Now afterwards you will be, I think, some big issues as the material develops some adhesion against the steel mold or other material. And on the other side also, as we saw, the curing or gel time is quite long. So typically you're using an injection molding process to have a really high throughput regarding the fabrication of the lenses or parts. So this material is initially not designed for injection process. Thank you.
Again, for Julian, can you explain self-adhesion? I haven't understood why the product is better than other 2K silicones.
Yeah, indeed, good question, and I think that's the aim of the presentation. So important to address this one. So existing two-component silicones are again optical two-component silicones actually in the market are not self-adhering. So basically, if you just mix the two products and apply it on your substrate, it will not build adhesion, meaning that you can peel easily the product from the substrate. So it will leave a clean surface. To have the adhesion, you need to apply a primer, and the adhesion is key for the application if you want to have a reliable luminaire. So because if you have no adhesion, you can have the encapsulant delaminates between the board and the encapsulant itself, which can lead to moisture condensation and at the end electrical defect. So if you don't have adhesion, at the end, if you apply your luminaire outside or in high humidity environment, it will lead to defect or poor reliability of them. So that's why majority of the customer using two-component silicones are using a primer to build this chemical adhesion. The ultimate objective of this product is to avoid this step. So you don't need to use any primer. The product is self-adhering. So everything is contained in the product to build adhesion on the substrate.
Is a diffuse material or mixture possible with this new silicone?
So for the moment, it's a really clear solution, so a transparent material that is available. Now we could help to case by case develop any diffuser or opalescent material that the customer could process in-house for their final application.
So what is the shelf life of EI-2888?
So shelf life is 1 year, so easy to answer.
This person says, sorry if I missed it, but can I immerse in water after encapsulating and in particular with a 120 volt AC electrical circuit?
Good question. Typically, we are not recommending such applications, such immersion application as first of all, we need to know the nature of the water and a lot of chemical interaction that is possible with the silicone, and on top of that, it really depends on the application. So this is really something we have to check case by case, and what is the purpose to have the fully immersed luminaire in what kind of water.
So is there any issue with chemical compatibility with the existing silicone dome on high power LEDs in regards with VOC contamination?
No, we have tested on various type of LEDs, and majority of the time when you have any kind, high power, mid power, low power, we have not seen any issue of compatibility with that, and those were run for several thousands of hours. This was not expected, by the way, from the knowledge of the technology itself, to have any issue, and this was validated with some testing and various testing in real applications.
This attendee states, we abandon using any encapsulants due to inconsistent color shift, and products even within one batch had different colors sometimes. How do you achieve a consistent color with your encapsulants?
I think this is the first time we heard something like that. As you saw, we did some real-life testing, and every LED had the same color CCT. And typically, I would say if you have some color change in your LEDs because you have some thickness differences in your protection solution.
So, optical question here: what is the refractive index of the material, and also what is the shrinkage during curing?
So the refractive index is a standard one for silicones in the 1.41 refractive index. So the other one, sorry,
Shrinkage.
the shrinkage. So basically that's similar to any other type of silicones. There is let's say no shrinkage. In reality, this is not 100% correct, but it's very below 0.1% or something like this. So hardly noticeable, and nothing to compare with organic chemistry in terms of shrinkage, and also no exothermic reaction. So basically, it will never heat when you mix the two products. That can lead also to stresses on the component where you have sensitive component that can support a lot of heat.
Here we have an attendee ask, are there test reports available? And further ask, is there information available on applications? And I assume he means specific applications across the range of solid-state lighting.
As the product is newly launched, it's very difficult to share some really case studies or application notes. But yeah, feel free to really ask any additional complement for information, and we will be more than happy to answer your request.
Yeah, to complement on that, we have plenty of data available, but as the product is a really new technology, everything that was done so far has been done under non-disclosure agreement with all our customers, so you can easily understand that it's not something we can share at this moment in time, as we are just launching this new technology on the market.
We have an availability question. What is the lead time for this product? We've had problems in the recent past due in part to whole or raw material issues.
Yeah, hello, it's Constantine speaking. So I'll take the question on the lead time, and I understand that for many people it could be painful in the recent past because the whole market was quite short. So for these products, first of all, we do expect these to be available globally, and we are opening up it for sales globally in all the regions that Dow is operating. With regards to the exact lead times in your region, please contact your closest distributor, and we will make sure that they do have a stock and there is a stock in your region. So it should be quite short. For those guys who is based in Europe, it's a little bit more advantageous, but we will make sure that it's equally easier for everybody around the globe.
The very simple question here, how long does it take to harden?
Simple question, but not so easy to answer. As I explained, the products start to form a gel first when you expose it to room temperature within 6 to 8 hours. If you apply heat, this is divided by 2 or 3 up to 50, 80 degrees. And then the product continue to build the hardness over time with exposure to moisture mainly. And of course, if you apply heat again, this will go faster. We can consider that we need several days, let's say 1 week, to reach substantial hardness that the product can support majority of the application. But the product is already solidified within 6 to 8 hours. But it start to form a gel, so very soft material that will increase in hardness over time. So that's why we were saying it's a little bit of somehow disadvantage for some application, but on the other hand, that was the only solution to have all the other features in terms of self-adhesion, cost, and cure robustness all together.
Constantine, we have another availability question asking about various production sites, and specifically this person asked for a production site in China, and does Dow China support this material?
Yeah, that's a good question. So first of all, I would revert it to you guys. Of course, it will pretty much depend on your demand, and we will be happy to support growth demand for innovation. At this very moment in time, the product is produced in Europe, and we are pretty much open-minded people when it comes to the supporting growth.
And we're getting to the top of the hour, but let's do one more. From a cost standpoint, what's the relative percentage difference between existing silicone composite versus the new 2888?
Yes, Constantine speaking. Let me take this one. I will not go into the exact percentage details, which most probably you guys, as most of us are engineers, would expect, because we simply don't know from which manufacturer you may use the silicone today. I would simply tell you, all our distributors around the globe, they already got the cost guidelines or price guidelines for this material. So please reach out to your closest distributor, and you will get the exact quotation, and you will make your own conclusion. We were targeting that it should be substantially lower than the currently available silicone materials. Again, from the price to comparable price per kilo, do not expect it to be the same as polyurethane, but take other advantages into account, and I'm sure it will be good for you in terms of cost as well.
Very good. So we have other questions we're not going to get to, but I'm sure the folks at Dow will be happy to get back to the rest of you who have questions that went unanswered. On behalf of LEDs Magazine and Pinwell, I'd like to thank our speakers today, Julian, Thierry, and Constantine, for a really excellent presentation and what was a very lively Q&A session. And certainly also like to thank Dow Silicones for making this presentation possible. The presentation, Stick to the Clear Advantage, new patented DOWSIL EI-2888 primerless silicone encapsulant for LED lighting, will be archived within 24 hours. You will get an email with a direct link to that archive. You can always get to our archives also just from our homepage, ledsmagazine.com. And most of all, for you in the audience, we certainly know your time is valuable. We really appreciate you spending some of it with us. Thanks a lot for attending, and we certainly look forward to serving you with future webcasts. Have a great day.